Okay, hello, welcome back. Wait for a couple more people to join us, I guess. Hi, can you go over the format of chapter 11 exam will be like? The homework has a lot of multiple choice questions, so I was wondering. Sure, I can go over that. Okay, let's see what we got here. Screen, get rid of this guy. Okay, so where are we at here? Subassign. Okay, as it stands right now, chapter 11 exam. Okay. Let's do edit. Okay. Has, what these based on 20 students? Okay. What is the XP? I don't know. I don't know what to, let me stop my share for a second. I don't think there's any multiple choice questions. Let me look real quick and see what we're looking at here. Okay, it says find the formula for the nth term. Determine whether the geometric series is convergent or divergent. No, they're all single answers. Use the integral test. Determine if the series converges or diverges. Does the series converge or diverge? Basically, you got a 50-50 shot at these. But you have to you got to share your work. Otherwise, you're not going to get the other half of the points. Does the series converge or diverge? Alternating series test. Use the ratio test to determine whether the series converges or diverges. It's basically all converges or diverges. Test the series for convergence or divergence. Test the series for convergence or divergence. Test the series for convergence or divergence. Find the radius of convergence. Find a power series. Find a power series. Expand the function as a power series. Find the Maclaurin series. And, oh, this is an application. I might get rid of this one. I want to delete this one. That's it. So, yeah, so just a lot of, is the series convergent or divergent? And basically it's just, proving convergence or divergence. So there are 14 questions in all. So half of it is getting the WebAssign answer right and half is showing you work. Yes, that's correct. Could you go over number 11 on 11.5? I can't do that right now. I want to make sure I get through all the notes. I'll do that at the end. Okay. Okay. Okay, 11.6 and 11.7 I want to cover today. Let's go ahead and do that. Okay, we talked about alternating series. So now let's talk about the ratio and the root test. Yes, nice. Okay, I like the ratio and root test. They're fun. Okay, so let's do a definition. Okay, whose mic is on? Turn your mic off. Mute all of you. Okay, definition. Hopefully y'all can see my screen. Okay, definition. A series a series A sub n is absolutely convergent if the series of the absolute values is convergent. If the series of the absolute values is convergent. Okay, is convergent. Okay, so that is the sum of the absolute value of A sub n is convergent. Okay, let's see, let's look at absolute convergence here versus just convergence, right? Because we could have something be convergent, but not necessarily absolutely convergent, okay? So we want to see, one, is the series, so which do you want to do? One that is absolutely convergent first, or do you want to do one that fails? Let's do one that is absolutely convergent first, and then we'll do one that's not. Okay, that's just convergent. Okay, so is the series the summation n equals 1 to infinity? We have problems? Is there a problem? Okay, what is the test called? There's no test yet. We're leading into the ratio test. This is a definition. Definition. Okay, it's defined as absolutely convergent. Is the series, okay, is the series n equals 1, okay, of -1 to the n minus 1, okay, to the 1 over n squared, is the series absolutely convergent? Oh, here, let's write it like this. Is the series absolutely convergent? Convergent or divergent? Okay, so what do we know? Well, we know that it's convergent. We could prove by the alternating series test. That's a question mark. By the alternating series test, is this gonna do this again to me? Alternating series test, hopefully it doesn't. alternating series test. Okay. Okay, by the alternating series test, we know that this is -1. Well, they're decreasing, right? So 1 is bn plus 1 less than or equal to bn. Are the terms decreasing? And we could easily prove, yes, that 1 over n plus 1 squared is less than or equal to 1 over n squared for all n. Okay, just, yes, it's going to go down. Okay. We could cross multiply, we could prove this. We could do that real quick. Okay, it's not too tough. This is n squared. Okay, n squared is less than or equal to n squared plus 2n plus 1, right? So, you know, and then subtract off n squared. That guy's gone. So this is 0 is less than or equal to 2n plus 1. Okay. Is 2n plus 1 always bigger than 0? Yeah, it is. We're good there. Okay, because n is all for n greater than or equal to 1. Yes, it's true. Okay. So you can prove that that's true for when n is greater than or equal to -1/2, which it is. It always is. Okay, and number 2, are these decreasing? Is the limit as n goes to infinity of 1 over n squared, does that equal 0? And yes, it does. Check. Okay, so by the alternating series test, this thing is convergent. Okay, but is it absolutely convergent? Okay, it does. This thing, the sum of the absolute value of -1 to the n minus 1 times 1 over n squared, does that thing converge, right? So what is that? Well, that thing is just the terms, but without the alternating, right? So instead of having 1 over 1 minus 1 over 4 plus 1, plus 1 over 9, okay, and then minus 1 over 16, right? What are we going to get? We're going to get these absolute valued, okay? These absolute values, then this is like a plus a negative, and so we get 1 plus 1/4 plus 1/9 plus 1/16. So the absolute values of these things, basically we just negate the -1. So the absolute value of this thing is just the sum of 1 over n squared. And we want to know, is that thing convergent? Does that thing converge? And yes, it does. This thing is convergent. This thing converges as well because it's a p-series greater than 1. Okay, p-series greater than 1. So that thing converges. So not only does it converge, okay, not only does it converge, but it is absolutely convergent. Okay, so not only does the original function converge, but by the alternating series test, but it is absolutely convergent. Okay, so we're going to say that the sum of -1 to the n minus 1 over 1 over n squared is absolutely convergent. Okay, and what we're going to be able to see is that if we're absolutely convergent, aren't we? Doesn't that imply also that it is convergent? Right? Doesn't that imply doesn't absolutely convergent imply convergence? Doesn't go the other direction though. Okay, convergence doesn't imply absolutely convergent. Okay, and let's see why it doesn't go the other direction. Okay, let's look at number 2 here. Okay, number 2. Okay, is the series, the alternating series, -1 to the n minus 1 of 1 over n convergent, absolutely convergent, or divergent. Okay, and the idea is that if we can get this thing to be absolutely convergent, then we can prove convergence. Absolute convergence implies regular convergence. It's convergent. Boom, done. Okay, but this is only convergent. Why is it only convergent? Because, okay, the sum of -1 over 1 over n to the n minus 1 is convergent. This thing converges by the alternating series test, or I'll just call it AST, alternating series test. Okay, but the absolute value of -1 to the n minus 1 of 1 over n is equal to the sum of 1 over n, which we know is divergent by it being the harmonic series. It's still blurry? Okay, is there anything I can shut off? Let me get rid of that. I don't know. I don't know why it goes blurry. Oh, turn off the face cam. Thank you. Very good. Yes. There we go. Turning off my face cam. Okay. I won't have to worry about that when I get my new system, because that'll be all. I'm only going to be using this as a tablet and not as any, not as to do any Zoom meetings or anything. Okay. Let's see. Yeah. So let's share the screen again. Let's try it this way. Okay. Better? Okay. Okay. So it is divergent, right? So it is convergent, but is it absolutely convergent? No, because the absolute value diverges. Okay, so we can only say that the sum of -1 to the n minus 1 over n is convergent. It is not absolutely convergent. Okay. Okay, definition. Definition. Okay. What does it mean when it's not absolutely convergent? Okay. Oh, then we say that it is conditionally convergent. A series, not Hey Siri, a series. Okay, a series. You're going to do it again, aren't you? Okay, I'm not going to. Okay. Summation a sub n, okay, is called, okay, conditionally convergent okay, conditionally convergent if it is convergent but not conditionally convergent, but not absolutely convergent. Okay, so again, okay, if it is just convergent and not absolute convergence, then it's conditionally convergent. Okay, however, if it is absolutely convergent, then that implies that it has to be convergent. It's almost like convergent. Okay, just think of it like this, okay? Absolute convergence is in here, right? Absolute convergence is convergent. Okay, so the things that are absolute convergent are also convergent. Okay, but the things, so this is all convergence. Maybe I should say the whole thing, the whole world here is the convergence. And the whole world over here is divergence. Right? Things that are convergent aren't divergent and vice versa. Okay, but the things that aren't absolutely convergent but are just convergent are conditionally convergent. Okay, so conditionally convergent, it's still convergent, but it's just not absolutely convergent. But if you're absolutely convergent, you're convergent. Okay, if I can prove that you're absolutely convergent, then I can prove you're convergent. Okay, you converge all the time. Okay, so that's what we're going to do. Okay, so actually, let's do one more where we're determining if it's convergent or divergent first. Okay, so number 3 here. Okay, determine if the series the summation of n equals 1 to infinity of cosine n over n squared is convergent or divergent. Okay, is convergent or divergent. Okay. Okay, so let's write out some of the terms of this guy. Okay, so what does this guy look like? Summation n equals 1. Okay. Okay. Convergent, and we can put under here, is it absolutely convergent or conditionally convergent? Right? Because it could be convergent, but we don't know which one. Was it absolutely convergent, or is it conditionally convergent? Right? Which one is it? Okay. So let's think about this way. Okay. I know that this thing, I can prove that this thing is convergent, but I don't know if it's absolutely or conditionally. Okay, so how can I prove that this thing is convergent here? Well, we have the cosine of n, it's not the con of n, the cosine of n over n squared is equal to the cosine of 1 over 1 squared plus the cosine of 2 over 2 squared plus the cosine of 3 over 3 squared plus the cosine of 4 over 4 squared, right? So what do I know about these terms here? Okay, these terms, I know that, well, let's look at the absolute value of these terms. Okay, let's look at the absolute value of the terms. Let's look at if it's absolutely convergent or not. Let's see if this thing is absolutely convergent or not. Does it converge absolutely? Because the idea is that some of these could be positive and some could be negative, right? Negative values, positive numbers, negative numbers. I don't know if it alternates. They might not all alternate. They might get some positives or some negatives. So what I want to do is kind of eliminate the fact that I could get negative values here. and just focus on the positive. So what I'm going to do is I'm going to say, let's look at n equals 1 to infinity of the absolute value of cosine of n over n squared. Okay. Well, isn't that equal to the absolute value of cosine of n over n squared? Why can I get rid of the absolute value on n squared? Because anything that would be squared is already positive. So I can get rid of those absolute values. Okay, where the absolute value of cosine of n is less than or equal to 1, isn't it? Isn't that always less than or equal to 1? Right? Okay. So what? So this thing, the absolute value of the function, okay, summation n equals 1 to infinity of cosine n over n squared is less than or equal to the summation of n equals 1 to infinity of 1 over n squared, right? How do I know that? Well, we just set it up. If the numerators are less than or equal to each other and the denominators are the same, then the fractions are less than or equal to each other, right? So we could then go, oh, let's just divide these by n squared. Oh, okay. So yeah, so what are we doing here? Well, we're setting up the basic comparison test, right? So this is, so by the basic comparison test, right? By the basic comparison test, since n equals 1 to infinity of 1 over n squares converges, then so does this guy, n equals 1 to infinity of cosine n, cosine n over n squared also converges. Okay. So why? Because if I get something that converges, okay, but it's bounded above by a converging sequence or converging series, then this thing, it would itself have to be converging, okay, because it's bounded above. This is 1 over n squared that it's bounded above by. So it's got to converge. It's being forced to converge. Okay, so that thing converges. Therefore, what? Therefore, this thing, n equals 1. Oh, thank you. Infinity. Are you going to finish your drink?
No, you want it?
Yeah, please. Okay, therefore, n equals 1 to infinity, okay, of the cosine of n over n squared, thank you, is also, is what? Well, it's absolutely convergent. Not only is this thing convergent, but it's absolutely convergent. There you go. That's cool. Okay, so this thing converges, is absolutely convergent. Okay, so, haha, happy face. Okay. Those are my eyebrows. I got some wicked eyebrows. So we'll do wicked eyebrows there. It's a happy face with the wicked eyebrows. And put some ears on me. And put some cat ears. I don't know. I give up. It's all good. I can't draw at all. Forget it. I give up. Okay. Okay, the ratio test. Ratio test. Test number 7, I think we're at. I don't know. I lost count. Okay, test number 7. The ratio test. no, test number, I think it's 9. What are we at? We're at 9. I think we've done 8 tests already. Ratio test, alternating series, harmonic, n-term, integral, string series, p-series, ratio, comparison. Yeah. That's number 9. Number 9. Or ratio test. Number 9. Ninth test. Test number 9. Okay. So here's the ratio test. Okay, if the limit as n goes to infinity of a sub n plus 1 over a sub n is equal to L, which is less than 1. If the ratio is less than 1, then the series summation of a sub n is absolutely convergent. Absolutely convergent. And thus convergent. Thus convergent. Okay, it is absolutely convergent and then thus convergent. Toxic bell. Take a little bite of my snack here. It's Taco Tuesday, but on a Wednesday. Is it Wednesday? No, it's Tuesday. It's Taco Tuesday on a Tuesday. There you go. That's why I got tacos. Okay. So Taco Tuesday. It's from Toxic Belch. Okay. Anyway, then the series is absolutely convergent. Okay, thus convergent. Okay. If the limit as n goes to infinity of a sub n plus 1 over a sub n is equal to L, which is greater than 1. If this comes out to be greater than 1, then the series is divergent. Okay, if the limit as n goes to infinity of a sub n plus 1 over a sub n is equal to 1, okay, this thing equals 1, then use another test. Use another test. Okay, it's inconclusive. The test is inconclusive. It's inconclusive. Okay, so let's test a series using the ratio test. These are always fun. I like them because I get to cancel stuff out. I don't know. I like to see the beauty of the test, I guess. What kind of taco? Oh, it's just a Del. I think it's called the Del Taco from Del Taco, and they're on sale on Tuesdays because it's Taco Tuesday. So, yeah. So I didn't even ask for them to deliver Del Taco tacos to me, and they did. So somebody must care about me. So I don't know. That's kind of nice. It's kind of nice. I don't know who cares about me, but I mean somebody in my family. But they feed me occasionally, which is a nice thing. Okay. So let's do a test here. Let's do a test. Okay, test the series. negative 1 to n of n cubed over 3n, n equals 1 to infinity for convergence. I want to test this for convergence. Okay, let's test this for convergence. Okay, so let's see how this works. So the limit, as n goes to infinity, of a sub n plus 1 over a sub n, okay, equals the limit, as n goes to infinity, of n plus 1 cubed over 3n plus 1. Okay, that's just the n plus 1s over n cubed over 3n. Blah, 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 blah. Yeah. Okay, so now I want to flip these things upside down, and let's try to cancel some stuff out. Okay, so I've got n plus 1 cubed over, oops, forgot my limit. Let's move that over. Move over, sir. Okay, there we go. The limit as n goes to infinity, okay, of the absolute value of n plus 1 cubed over 3 to the n plus 1 times 3 to the n over n cubed. Okay, now how can we cancel some stuff out here? Well, I notice that I've got a 3 to the n plus 1 on the bottom and a 3n on top. Okay, I can think of 3 to the n plus 1 as 3 to the n times 3 to the 1, which is 3 to the n times 3, right? So can't this 3 to the n cancel with this 3 to the n plus 1 and just leave me 3 on the bottom? Well, that's nice. Okay, so this is equal to the limit as n goes to infinity of n plus 1 cubed over n cubed, and then I have a 1/3 on the front here. Okay, maybe I'll get rid of that 1. Okay. I'll put it there. 1/3, absolute value of that thing. Okay, let's see what this, let's continue with this. This is equal to the limit as n goes to infinity of 1/3, and then this thing I can rewrite as n plus 1 over n to the 3rd power. Nice. Okay, this is equal to the limit as n goes to infinity of 1/3 times 1 plus 1 over n to the 3rd power. Okay, and now let's plug in infinity. What do we get? Well, we just get 1 over infinity, which is 0. This thing goes to 0. Okay, 1 plus 0 is 1. 1 cubed is 1, and 1/3. So this thing is equal to 1/3, which is less than 1. Okay, therefore, since it's less than 1, therefore, I have proven that the summation of negative 1 to n of n cubed over 3 to the nth power is absolutely convergent. Absolutely convergent. Okay, by the ratio test. By the ratio test. Okay, so that thing is absolutely convergent by the ratio test. Nice. Okay. Okay, let's look at the root test real quick. The root test. Root test. If the limit n goes to infinity of the nth root of the absolute value of n, a to the n, is equal to L, which is less than 1, then the series Okay, summation n equals 1 to infinity of a sub n is absolutely convergent. Absolutely convergent. Okay, and thus convergent. Okay, is absolutely convergent and thus convergent. Okay, if the limit as n goes to infinity of the square root of n, absolute value of a sub n, is equal to L, which is less than, or sorry, which is greater than 1, or this thing goes to infinity, the limit as n goes to infinity of the nth root of the absolute value sub n equals infinity, then the series is divergent. Okay, so then it's divergent. Okay, and once again, if this is equal to 1, then it's inconclusive. Limit as n goes to infinity of the nth root of a sub n. If this is equal to 1, then inconclusive test. Okay. Okay, let's do a root test example. We want to test the series for convergence. Does this thing converge or not? Okay, and the series is summation n equals 1 to infinity of 2n plus 3 over 3n plus 2 to the nth power. Okay, so I want to test this thing for convergence, see what happens. Okay, so I'm going to take n equals 1 to infinity of the nth root of the absolute value of 2n plus 3 all over 3n plus 2 to the, or sorry, to the nth power. Okay. Okay, so oh, blurry again. Okay. Stop the sharing. Wait a couple seconds. Go back. Do the sharing. The video thumbnails are minimized to optimize full screen video clip screen sharing. Okay, sounds good. Is that better? Yeah. Yeah, okay. Okay. Let's try the next one here. Okay, so this n and this n are going to cancel each other out. So we're really just interested, okay, we want the limit as n goes infinity of this thing, right? I can get rid of this. I just want to know the inside here. The limit as n goes to infinity, right? Okay, these are going to cancel each other out, is equal to the limit as n goes to infinity of, okay, the well, the absolute value of the top and the bottom, I don't really have to worry about that too much because everything's positive there. If n is greater than or equal to 1, then everything's positive, right? So I can kind of remove the absolute value bars. So I'm going to get 2n plus 3 over 3n plus 2. Okay, and then I can use L'Hopital's rule to say that this is the limit as n goes to infinity of 2 over 3, which is 2/3. Okay, and 2/3 is less than 1. Therefore, the summation of n equals 1 to infinity of 2 to the n plus 3 over 3n plus 2 all raised to the nth power, this thing is absolutely convergent. Okay, absolutely convergent. Okay, and that's 11.6. Okay, let's move on to 11.7. Okay, which is just basically, tell me if this thing is convergent or divergent. That's it. Half your exam on Tuesday is going to be, tell me if this is convergent or divergent. That's it. Okay, half. Okay, is it convergent? Is it divergent? Is it convergent? Is it divergent? Half. Okay, and then it's not like, oh yeah, it's convergent. It's why is it convergent? Prove it. Right, that's the hard part. Okay, so what have we learned so far? What have we learned so far? We've learned 10 tests. 10 tests for convergence / divergence. So let's list out the 10 tests, okay? You might want to have these handy right next to you while you're taking the exam. Okay, what are the 10 tests for convergence or divergence? Well, the first one, the geometric series test. Geometric series test. I can't spell. Series test. Okay, where the absolute value of r, where we have the summation of a, r to the n minus 1. Sorry, r to the nth, we'll do r to the nth. It was n minus 1 though, I think. Yeah, n minus 1. Okay, yeah, of n equals 1 to infinity, where if the absolute value of r is less than 1, then it converges. Otherwise, diverges. Okay. Number 2, the harmonic series. Okay, the harmonic series. Series 1 over n equals 1 to infinity, is always divergent. Did that one. Okay. Number 3, the nth term test. The nth term test. Okay, the nth term test. This is a test for divergence. Okay, so does the nth term, does the nth term go to 0? Okay, limit as n goes to infinity of a sub n equals 0. Okay, and if it does not, okay, if it does not, then it's divergent. Okay, does the nth term go to 0? No. Divergent. Can it prove convergence? No, it cannot prove convergence. It can only prove divergence. But if the terms are not getting smaller, it's going to diverge. Okay, number 4, the integral test. Integral test. Okay, integral test. This is 1 to infinity of a sub n. Okay, is if this is convergent, this implies convergence. If this is convergent, then the original series was convergent, then A sub n is convergent. So if the integral is convergent, I'm going to get rid of the implies. I don't like the implies. I'm going to say, if this thing is convergent, if the integral is convergent, then the original series was convergent. Oops. I just need an if. If this is convergent, then A sub n, the summation, A sub n, is also convergent. That's the integral test. The integral test. Okay. Oh, and if it was divergent, then it's divergent. If 1 to infinity of A sub n is divergent, then A sub n is also divergent. Okay, number 5. Okay, comparison test. A comparison test. Okay, if B sub n is convergent and A sub n is always less than B sub n, then A sub n is convergent. Okay. Okay, if A sub n is divergent and A sub n is less than or equal to B sub n, then B sub n is also divergent. More blurriness? What the heck, man? Okay. Divergent, and A sub n is less than B sub n, then B sub n is divergent. Okay, number 6. Limit comparison test. Okay, limit comparison test. Okay, if the limit as n goes to infinity of A sub n over B sub n is equal to a constant greater than 0, then both converge or both diverge. Both A sub n and B sub n both converge or both diverge. Okay, number 7. Okay, alternating series test. Okay, alternating series test. Okay, what's the alternating series test? Well, okay, if we have summation -1 to the n b to the n of n equals 1 to infinity, okay, it's convergent if 1, b sub n plus 1 is less than or equal to b sub n, and 2, the limit as n goes to infinity of b sub n is equal to 0. Okay, then it's convergent. Okay. Number 8. Okay, number 8 is, this should have been, I should have done this one a lot earlier, but that's fine. Number 8 is the P series. Okay, P series. So A sub n is equal to 1 over np, or P is greater than 1, then convergent. Then A sub n is convergent. Okay, then A sub n is convergent. Okay, number 9 and number 10. We just learned about this, right? Okay, number 9, ratio test. Ratio test. Okay, what did the ratio test say? Well, if we take the limit as n goes to infinity of a sub n plus 1 over a sub n, okay, if that is less than 1, convergent. If it's greater than 1, it's divergent. And if it's equal to 1, we don't know. Equals 1, don't know. Okay, use another test. Try something else. Blurry again. Nice. I don't know why it suddenly decides to go blurry, and why it suddenly decides not to go blurry. The world may never know. Okay. Okay, and number 10, the root test. The root test. Okay, the root test. Okay. Okay, the root test, the limit. Okay. The limit as n goes, oops, n. The limit as n goes to infinity of the nth root. Okay, the nth root of the absolute value of a sub n, if that is less than 1, greater than 1, or equal 1, then it's convergent, divergent, or try something else. Okay. Okay. Is that good? You got your list? You got your list of 10 there? That's good. That's good. Okay, number 1. Which test should be used for which test should be used for? Okay, we're going to set up five of these. Which one, what should we use this for? So just kind of shout it out in the comments if you know the answer. Okay, just say, hey, that's divergence test. Or hey, that's limit comparison test. Now there's more than one right answer for some of these. So, but oftentimes there's a best answer, right? It's like, which one's going to be the least amount of work for me to do? Because I'm lazy. Oh. Everybody's going to go eat tacos now, aren't they? And they're like, my professor, He was eating tacos for Taco Tuesday. During this is my lunch hour that I'm teaching, so it's really hard for me to go 3 hours without eating, especially since I like to eat. So I used to think I was hypoglycemic because I just snacked all the time. I was hungry all the time. But then my doctor, he's like, no, you're not hypoglycemic. You just like food. Like, oh, okay. There you go. I guess, you know. Yum, yum. Okay. Okay, so let's do a little shout out here. What test should we use? I feel like I'm teaching high school again. What test should we use for this one, Johnny? Why is it always Johnny? Okay, Jaime. I gotta say Jaime. Okay, Aaron. Okay, which test should be used for this one? Ideas? Okay. Nth term test. Nth term test. Integral test. Okay. Let's see. The integral test. Is that thing easily integratable? Can I easily integrate this thing? Probably not too easy to integrate that. I don't know. I would have to split it up, I guess. I don't know. It might be easily. I don't know. I would know I'd have to do some long division, I think. Right? I mean, I could break it up over 2n plus 1, integrate this thing, right? I mean, if it's an easy integration, then by all means. Okay, 2n plus 1. Okay. This is going to be a natural log. I might have to do a limit of a natural log type of thing. Okay, 1 to infinity. You know, I don't know if this is going to be too easy to integrate. I'd have to do a long division on that. And that's going to be a pain in the butt. So, yeah, this thing actually has an asymptote, right? A sub n has an asymptote at 1/2, okay? So the limit as n goes to infinity of a sub n here is equal to 1/2. Therefore, it is not equal to 0. Therefore, it diverges. What do we call that? We call that the nth term test or the divergence test. Okay, so this one is nth term for A. Nth term. Okay, or divergence, however you want to call it. Okay, B. What about B here? Okay, B. Ba. 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 Okay. N equals 1 to infinity of the square root of n cubed plus 1 over 3n cubed plus 4n squared plus 2. Things that make you go, What might I want to do with this one? Okay, the root test. I might, if the top and bottom were both rooted, although they're both raised to a power here. I don't think root test. Victor says comparison test, and Victor is absolutely right. There's a shout out to Victor. Comparison test. Let's compare to. I mean, it's a good thing to try. Compare to what? Compare to n to the 3/2 over 3n cubed, right? So compared to this thing, right? Okay, so let's reduce this. This is going to be 1 over 3n to the 3 halves. Okay, and so what is this? Okay, this is, okay, this is what? Oh, I might end up with a problem here. I have a problem. Because this guy converges. Doesn't this guy converge? Converges, right? No, I think you're right. I think we're good. Are we good? Because I just want this guy to be smaller. Right? Let me think about this for a second. This guy converges because it's a P series, right? P series. Okay, it's a P series. Okay. Okay, it is a P series, so that thing converges. And is this thing gonna be smaller though? That's what I want to know. Is the square root of n cubed plus 1 over 3n cubed plus 4n squared plus 2, is that always going to be less than or equal to 1 over 3n to the 3 halves? And I believe it is. It is. Yeah, I think it's checks out. So yeah, comparison test. Boom. Good. Okay, it is. Okay, if we can bound it by something above that we already know converges, then we're good. So it was comparison test to a P series. So it's kind of two in one there. Okay, so that thing, yes. Okay, comparison test. Okay, number C, letter C. Okay, ooh, this one's spicy. N equals 1 to infinity of NE to the negative n squared. NE to the negative n squared. Okay. Okay, any ideas on this one? Geometric? Integral? Okay. Jamson, did you put integral for that one? Yes, okay. Yeah, so I would go with integral on this one. Okay. Geometric, not so much because we don't have an A times something. We have actually a power to a power here. So that would not be geometric. Okay, but I could do an integration by parts on this thing. And you know, go take 1 to the infinity of n to the, oh, you know what? I don't even have to do an integration by parts. This is so sweet. Why is it sweet that we don't have to do integration by parts? Because if I let u equal negative n squared, then du is equal to negative 2n. And look at that. There's my n dn right here. Ooh, look at that. So yeah, integral test all the way on this one. Okay, integral test. Nice. You just do a UDU sub. Okay. What about D here? D. Oh, this one's an easy one. This one's a softball. Okay, negative 1 to the n cubed over n to the 4th plus 1. What do we do with this one? Okay, Achilles says, alternating series test, and he would be absolutely right. Okay, alternating series test. Is there something else that we could use for this alternating series test? Is there anything else that we could use? Ratio, yeah, Gene, I would say ratio as well, yeah. Ratio, because what happens when we do the absolute value, doesn't this term just go away? Right, and then we could do a ratio on that as well. Although, let me think, ratio, will the ratio test work? Let's do a ratio test real quick. Let's see if it works, okay? Is the absolute value of -1 to the nth of n cubed over n to the fourth plus 1, is that going to give me what my desired result here? Okay, right? So I want the absolute value of this thing. Okay. Right, absolute value of that. Oh, wait. Here, this is what I want to do. Okay, so let's do a ratio test on this. The limit as n goes to infinity of a sub n plus 1. So this is -1 to the n plus 1. N plus 1 cubed all over n plus 1 to the fourth plus 1. Okay. N plus 1. Okay, all over. I'm just going to break it up into two absolute values. All over -1 to the nth, n cubed, all over n to the fourth plus 1. Boom. Okay. Okay, so now let's flip. Let's divide and flip. It's blurry again. Okay, let me stop my share. Let me count to 5. 1, 2, 3, 4, 5. And let me share again. Boom. Okay, hopefully that's better. Okay, so then this is going to be, okay, times negative, or this is going to be n plus 4, or n plus 1 to the fourth, all over -1 to the nth. Okay. Okay, and then times n cubed. Okay, so I can drop the -1 here if I really want to, because the absolute value of -1 to any power is just 1. Okay, so we could also see that in that this guy and this guy are going to cancel. This guy here, they're going to cancel and just leave me one -1. Right? So that cancels with this. And so I'm just going to have -1 to the first power, which is just -1. And what's the absolute value of -1? It's just 1. So there you go. So this thing is equal to, I'm going to write it like this, n plus 1 cubed over n squared, or sorry, n cubed, times n plus 1 to the fourth over, is that right? No, that's not right. This should be n to the fourth plus 1. I wrote this wrong. N to the fourth plus 1. Okay, and this is going to be n to the fourth plus 1 over n plus 1 to the fourth plus 1. Okay, and we want to take the limit of this thing as n goes to infinity. Okay, so let's go, let us do that. Okay, let's take the limit of this thing. Okay, so here, this thing is going to be the limit as n goes to infinity of what? Of this thing, okay, is going to be n plus 1 over n cubed, or sorry, n cubed, right, times, okay, and this is going to be n to the fourth plus 1 over Okay, n plus 1 to the fourth plus 1. Okay, so there we go. Okay, this thing, I should be able to convince you that that's going to go to 1. Okay. Is everybody okay with that? That thing going to 1? Because that's just going to be 1 plus 1 over n. 1 plus 1 over n. And this thing's going to go to a 0. And so 1 plus 0 is 1. Does that make sense? Okay, is that good? Okay, so that's going to go to 1. And then 1 cubed is just 1. That's going to go to 1. So this thing goes to 1. That goes to 1. 1 times this thing now. Let's convince you that that thing goes to 1. Okay, let's convince you that that thing goes to 1. Well, why does that thing go to 1? Because the first terms here are n to the fourth plus 1 over n to the fourth plus, I'm just going to say something, right? So then this thing actually goes to 1. Oh, well, that kind of sucks. If you did it, and how would I know that this thing goes to 1? Because if we took L'Hopital's rule repeatedly on this thing, it would eventually go to 1, because I'd get the exact same thing at the top as the bottom, because I'm getting the exact same power on the top as the bottom. So this thing goes to 1, which kind of sucks, because why? Because the ratio test is inconclusive. So we cannot use a ratio test there. All alternating series test. Oh, nice. Okay, that's cool on that one. Okay, what about E here? Let's look at E. E is the summation n equals 1 to infinity of 1 over 2 plus 3 to the n. Okay. Okay, what are we going to do here? Any ideas in this one? What test could we use here? What would be a good test for this one? So more in the center. There's my notes. Okay, what do you got here? Okay, geometric. Well, sort of, except that it's not quite geometric, because we are adding that 2, right? We're adding that 2. So it looks geometric except for the 2 on the bottom. So that's kind of a problem. But we could think of it in terms of a geometric, right? It's not a p-series because n would have to be on the bottom. I mean, it's really close. It looks like this guy. Okay, doesn't it? It just looks like 1 over 3 to the n, which is 1 over 3 to the nth power, right? So it looks like this guy, and that guy we know converges. We know that guy converges. Why? Because he's geometric, right? He's geometric. So there you go. Yeah, comparison, right? We want to compare this one to this guy, right? We want to compare. So this is comparison test again. So that's comparison because this is 1 over 2 plus 3 to the n, which is always less than or equal to 1 over 3 to the nth power. And since this one converges, and we get a smaller one that converges, okay, then that one will have to converge as well. Okay, so geometric was on the right track. We just had to use the geometric as a comparison. Okay, so hopefully that makes sense. Okay, okay, let's do one more example here of this type of problem. Okay, Could we have done, actually on E, could we have done the ratio test? Is the ratio test allowed? Or is it inconclusive? Let's see. Ratio test? Could we do the ratio test on that one? We might be able to. I don't know. We'll see. See what happens here. Although I don't know about that extra 2 there. Okay. Yeah. Okay, ratio test. 1 over 2 plus 3 to the n plus 1 over 1 over 2 plus 3 to the n. No, that's not going to work. It's just going to be, it's not going to get things to cancel out that are nice. So nope, it's not going to work. Okay, number 2. Number 2. Okay, summation, okay, of k equals 1. I'll just do n. Make it easy. N equals 1 to infinity of 2 to the n over n factorial. Okay, so what do we want to use for this one? What do we want to use for this one? I'll give you a hint. Whenever you see a factorial, it's ratio test. Okay, it's ratio test all the way. Okay, whenever you see a factorial, automatically think ratio test. Okay. Okay, so why don't you try the ratio test on this? Does everybody know what a factorial is? Does everybody know what a factorial is? It's when I do n factorial, that's n times n minus 1 times n minus 2 dot 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 all the way to 3 times 2 times 1. Does that make sense? That's n factorial. Okay. So this is going to be ratio test. Okay, ratio test. Why? Because the n factorial and the n plus 1 factorial, they're going to cancel out really nicely when we use the ratio test. Okay, it's all about utilizing the algebra that we know. Okay, so we're going to say the limit as n goes to infinity of, okay, the absolute value of 2 to the n plus 1 over n plus, what the heck? How did that get in there? Copied something. Okay, n plus 1 okay. Okay, n plus 1 factorial, okay, divided by 2 to the n over n factorial. Okay, so this, I'm going to flip this upside down and multiply. This is n factorial over 2 to the n. Okay, I can bring them all under one, inside one absolute value. I can go boom, boom, right? Boom, there we go. Okay, so what is this going to be? Well, this is going to be the limit as n goes to infinity of, well, this 2 to the n plus 1 and this 2 to the n, they're going to cancel and just leave me 1, 2. So that's just a 2. Okay, what's n factorial? Well, n factorial is n times n minus 1 times dot, 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 right? What's n plus 1 factorial? Isn't that n plus 1 times n minus 1 all the way down? So what's going to cancel? Everything except for the n plus 1. So this equals the limit as n goes to infinity of 2 over n plus 1. The only thing that survives is the n plus 1. Everything else cancels out. That's why using the ratio test on factorials is really nice. Okay, we can have an absolute value there if we want. Doesn't matter because everything's positive now. Okay, and so what does this thing go to? Well, this equals 0. This is going to go to 0, which is less than 1. Therefore, this thing is convergent. Therefore, convergent. Okay. Okay, and that's 11.7. 11.8? I don't know. You guys want to move into 11.8 today? How much do we got to cover on 11.8? Let me stop my share for right now. What I'm going to do is I'm going to stop recording, and